In 1938, the legendary Charles Boss Kettering and his team at General Motors' newly formed Detroit Diesel Division introduced a clean sheet design that would change the world. They created a new family of diesels that would outlive the companies that bought them, the trucks that carried them, and sometimes even the mechanics who rebuilt them. For over 50 years, the Detroit Diesel Series 71 engines became one of the most widely used diesel platforms in American industry, and that name still echoes in shops and shipyards across the country. This isn't just another engine story. This is the story of how American engineers created a diesel platform so fundamentally sound and so exceptionally reliable that it became synonymous with industrial strength itself. For more than half a century, the Series 71 engines defined what unkillable actually meant. The America of 1938 faced a problem that went far beyond transportation. Gasoline engines dominated trucking, but they were reaching their limits. They couldn't provide the torque required for heavy hauling, they burned too much fuel on long-distance freight routes, and they demanded more maintenance than industrial fleets could sustain. Diesel technology existed, but it was heavy, inconsistent, and complex. European designs were refined, but not suited to America's large-scale manufacturing or field service expectations. Many American diesels were still evolving and often too expensive or unproven for widespread use. The military, watching storm clouds gather across two oceans, needed engines that could be built quickly and repaired in the field by mechanics who might never have seen them before. General Motors wasn't looking for the most efficient engine. They weren't chasing the quietest operation or the smoothest power delivery. They were solving for something more fundamental: absolute dependability under conditions that would destroy lesser machines. Developed by GM's newly formed Detroit Diesel Division, building on Winton's engineering legacy, the design team made decisions that would echo through decades of industrial history. They started with modularity. The Series 71 wasn't one engine, it was a system. The same basic cylinder architecture could be configured as an inline 1, 2, 3, 4, and 6, and later V6, 8, 12, 16, and the less common monster 24V71. Each cylinder was essentially identical. The same pistons, the same liners, the same valves, the same injectors. This wasn't just elegant engineering, it was strategic thinking. A fleet operator could stock parts for one engine family and service everything from delivery trucks to marine vessels. A military unit could carry repair components that worked across their entire diesel inventory. But modularity was just the foundation. The real innovation was in the operational philosophy. Detroit Diesel chose a two-stroke design when most of the industry was moving toward four-stroke engines. This wasn't stubbornness, it was calculated engineering. The two-stroke design prioritized power delivery and mechanical robustness over refinement. It meant simpler maintenance schedules and more predictable service intervals. The scavenging system utilized a mechanical roots blower as a fundamental necessity for operation. Because the Detroit diesel two-stroke cycle lacks an intake stroke, the blower was required to force fresh air into the airbox and through the cylinder ports to clear exhaust gases. Driven directly by the crankshaft via a gear train, the system provided a constant, reliable air supply, independent of exhaust pressure or electronic sensors, ensuring the engine could breathe from the moment it started cranking. The fuel injection was purely mechanical. No electronics to fail in harsh conditions, no sensors to corrode in marine environments. Just precisely machined components that delivered fuel at exactly the right moment every time for millions of cycles. The engineering philosophy went deeper than individual components. The two-stroke cycle simplified airflow management without adding additional cam-driven intake systems. Instead, intake ports were machined directly into replaceable dry cylinder liners. These liners were pressed into the block, providing a robust structure that could be pulled and replaced during an overhaul, returning the cylinder to factory new dimensions without ever needing to bore the block. This systematic approach to reliability extended to every aspect of the design. Because the intake was handled by the liners and the gear-driven roots blower, the rest of the architecture could remain modular. This meant a single set of tooling could produce components for any configuration. Mechanical unit injectors eliminated the need for separate high-pressure injection pumps and fuel lines. placing fuel metering and timing into a single rebuildable component. Most importantly, the entire system was designed to be repaired anywhere, not optimized in a laboratory. Every major component could be rebuilt with standard machine shop equipment. The design allowed field repairs without highly specialized measuring equipment. The modular architecture meant failed components could be isolated and replaced without complete engine removal. Then came the test that would prove everything. December 7, 1941, changed America's industrial priorities overnight. The country that had been preparing for war was suddenly fighting it on two fronts. The military needed engines, and they needed them now. Not prototypes or experimental designs, but proven, reliable power plants that could be manufactured by the thousands and shipped to theaters where failure meant more than inconvenience. So the Series 71 went to war. The scale was unprecedented. Detroit Diesel ramped production to deliver engines in massive volumes, feeding an industrial machine that had to supply two global theaters simultaneously. The 671, built by GM Detroit Diesel Division under wartime contracts, powered thousands of landing craft and naval support vessels across both theaters, including many Higgins LCVPs. Each engine had to start reliably after weeks aboard transport ships, operate in heavy salt spray and corrosive marine conditions, and provide full power when lives depended on reaching the beach. The modular design that had seemed like elegant engineering became strategic advantage. Supply chains stretched across oceans could stock fewer part numbers while supporting more equipment types. A single shipment of cylinder kits could service marine vessels, generator units, and specialized military equipment, though most wartime trucks still ran on gasoline. Battlefield mechanics could cannibalize parts from damaged equipment to keep critical systems running. The standardized architecture meant training programs could prepare technicians to service any Series 71 application, regardless of configuration. Production numbers told the story of industrial mobilization. Tens of thousands of engines flowed from Detroit factories to support the war effort. They powered industrial machinery and marine craft that sustained the Allied logistics network. They powered generators that kept field hospitals operating and communication centers functioning. They powered the industrial machinery that built airfields in jungles and harbors on foreign shores. The larger 12 V-71 and 16 V-71 powered landing ships, armored recovery vehicles, and heavy stationary generator sets that demanded far more output than a single inline engine could provide. The military didn't just use these engines, they abused them. They ran them without proper maintenance. They operated them in conditions no civilian application would ever see. They pushed them past redline when the mission demanded it. They continued operating under abuse that would have disabled lesser designs. When the war ended, America faced a different challenge, building the infrastructure for a peacetime economy that would dwarf anything the world had ever seen. Laying the groundwork for post-war infrastructure projects, including the interstate highway system launched in the 1950s, transcontinental freight networks, urban bus systems that could move millions of people daily, and construction projects that would reshape the landscape. Highway construction crews relied on Detroit diesels to power the scrapers, dozers, and haulers that carved roads through mountains and across deserts. Inline engines like the 471 and 671 became common in cranes and smaller earth movers, while larger V12 configurations powered massive off-highway machinery that ran around the clock. These engines worked 12-hour shifts in dust-heavy conditions that tested cooling and filtration systems. They operated at altitude where other engines lost power, and they kept working in heat that melted tires and cold that cracked steel. By the 1950s and 60s, long-haul trucking discovered that engines like the 671 and later the 8V71 could deliver the torque needed to pull heavy loads up mountain grades while returning fuel economy that made transcontinental freight profitable. Urban transit systems adopted the inline 671 in early post-war buses, and later the compact 6V71 in rear-engine transit coaches for buses that needed to start and stop thousands of times per day, operate in stop-and-go traffic that would overheat other engines, and provide decades of reliable service with minimal downtime. Marine applications pushed the engines even further. Smaller commercial fishing boats often relied on the 471 and 671 for their balance of torque and compact size, while tugboats, trawlers, and coastal freight vessels frequently turned to the 671 and 8V71 for greater pulling power. In larger workboats and auxiliary ship systems, 12 V71 engines delivered the sustained output needed to run day and night in corrosive salt air. These engines weren't just transportation, they were lifelines, expected to start without hesitation and run for weeks at a time, far from shore and far from help. But it wasn't just the technical specifications that built the legend. It was the culture that grew around these engines. Drivers started calling them Screamin' Jimmies, a reference to the distinctive sound of the two-stroke operation and the GM badge that appeared on many applications. It wasn't a derogatory nickname, it was recognition and respect. You could identify a Detroit diesel from blocks away, and that sound meant reliability. But why did the Series 71 engines actually survive when others didn't? The answer wasn't mystical, it was mechanical. While gasoline engines of the era wore out at 60 to 100,000 miles, and many early diesels required expensive machine shop boring when cylinders wore, Detroit Diesel made four critical engineering decisions that changed everything. First, conservative power ratings. In typical highway trim, the 671 produced roughly 170 to 238 horsepower from 426 cubic inches. They weren't squeezing every possible bit of power from the design. The engines operated well within their mechanical limits, leaving margin for the abuse that real-world operation would inevitably deliver. Second, low piston speeds. With a 5-inch stroke and a 2100 RPM redline, Detroit diesel pistons moved much slower than gasoline engines screaming at higher RPMs. Lower piston speeds meant lower mechanical stress, less heat generation, and dramatically extended component life. Third, dry cylinder liners. When cylinders wore, mechanics could pull the liners and press in new ones, returning bore dimensions to factory specifications without ever touching the engine block. The block itself could survive multiple rebuilds, sometimes lasting decades longer than the original power rating suggested. Fourth, unit injectors. Instead of relying on complex external high-pressure injection pumps that could sideline an entire engine, each cylinder had its own self-contained injector. When one failed, a mechanic could swap it in minutes and keep the engine in service. No specialized tools, no system bleeding, and no downtime waiting for pump repairs. The foundation of this reliability was built into every component. The cylinder blocks were heavily cast to withstand sustained industrial loads, while crankshafts were forged from steel that could withstand stresses that would snap lesser components. Connecting rods were built like bridge girders, over-engineered for loads they would never see in normal service. The lubrication system used a gear-driven oil pump mounted directly to the crankshaft, no chains to stretch or belts to break. Even the cooling system reflected the overbuilt philosophy, with radiators sized for conditions far more severe than normal operation and water pumps, built for sustained operation in harsh working environments, including both seawater and freshwater variants engineered specifically for marine duty. The Series 71 was built to tolerate abuse that would destroy other engines, making them appear unkillable. Conservative ratings gave operators a margin of durability under sustained heavy loads. Robust construction meant they could handle occasional overloads without permanent damage. Mechanical simplicity meant they could continue operating even when auxiliary systems failed. For more than half a century, these engines defined what industrial reliability meant. But the world was changing around them. Environmental regulations began to tighten in the 1970s and 80s. The two-stroke design that had provided such reliable service became a liability in an era focused on emissions reduction. The mechanical fuel injection that had proven so dependable in harsh conditions couldn't provide the precise control needed to meet new standards. Four-stroke designs, once less favored for their complexity, gained ground as electronic controls made them more efficient. Advances in turbocharging and combustion design allowed four-stroke engines to deliver comparable power while consuming less fuel and producing fewer emissions. The industry's priorities shifted. Fuel efficiency became more important than absolute durability, Emissions compliance became mandatory rather than optional. Electronic diagnostics became standard rather than exotic. Detroit Diesel adapted, introducing four-stroke designs and electronic controls. But the Series 71, the engines that had defined the company's reputation, gradually faded from production. The last new Series 71 engines were built in the early 1990s, ending more than 5 decades of continuous production. But ending production didn't end the story. Today, decades after the last new engine was built, they continue to operate in marine applications where reliability matters more than emissions compliance, in industrial settings where durability outweighs efficiency, and in the hands of operators who understand that sometimes the old way is still the best way.